Hello again, math people. So I just wanted to go over section 2.4 today, and that's dividing polynomials. So our objectives for today are going to be to understand long polynomial division, to understand synthetic division by linear terms, and to apply the remainder theorem. So polynomial long division works just like regular long division. And then we'll get to the second part later. But for a quick refresher, let's say we want to divide 125 by 2. So 125 is called the dividend. And then 2 is going to be called the divisor. I like to think of it like 2 is the divisor, like it's the one dividing, and the dividend is going to end up changed. But anyways, so we have these two, and we're going to write this box here. And we're going to put 2 here and 125 inside the house. And so we're just going to start going over how much 2 goes into each term. So 2 does not go into 1, so we have a 0 here. And then 2 goes into 12 6 times, and we're going to subtract 2 times 12, or 2 times 6, which is 12. So then we're left with 0, 5, and we'd like to see how many times 2 goes into 5, and that is, of course, 2 times, and we're going to subtract 4. And now we're left with a remainder of 1 and a quotient of 62. So we say that 125 divided by 2 is equal to 62 plus 1 divided by 2. All right, so now in polynomial division, we're going to write that exact same thing. So let's draw this box here, and we're going to put x plus 2 here, and we're going to put x squared plus 3x minus 1 here. And so how many times does x plus 2 go into this first term? Well, the largest thing that I can put in, I want to cancel out this term right here, so I'm going to put an x. So we're going to subtract by x squared plus 2x. And when I do that, I'm going to get 0 here, and then plus x minus 1. And then this goes into x minus 1 one time, so minus x plus 2. And what we're going to be left with, this is going to become 0, this turns to negative 3, this is our remainder, and this is our quotient. And we see that this result is going to be x plus 1, our quotient, minus 3 divided by x plus 2, and that's our remainder. And you always want to write these terms in order and with placeholder 0, so I'll do an example with that. So this one is kind of messed up and out of order, but let's write it in order, right? So first, this is our first term, so we have minus 5x to the 4th. Then we have a cubed term, plus 3x cubed, plus 2x squared, that first term right there. And then we don't have a x term, so I'm going to say plus 0. And finally, minus 4. And we're dividing this by, right in order, negative x squared plus 1. So this time it's a bit different. Since we have a negative x squared, we're going to have to do a bit more fiddling. So how many times does negative x squared go into negative 5x to the 4th? That's negative 5 times. So negative 5x squared times, right? So we're going to subtract, or excuse me, not negative 5x squared. It's just 5x squared, right? So we're going to subtract negative 5x squared plus 5x squared, right? Because we're multiplying that inside. And when we do that, this is going to become 0. And then 3x cubed minus 5x cubed, Oh, and excuse me, that's where we need to write our leading zeros because I just made a mistake there. So it's actually negative x squared plus 0x plus 1, right? And so when we do that, we still have our 5x squared, and we're going to subtract negative 5x to the 4th plus 0x, and then plus 5x squared, right? And when we do that, we're going to get 0 here. We're going to get 3x cubed here. We're going to get negative 3x squared here. And now we're going to go again. So how many times can we put negative x squared into 3x cubed? Well, that's going to be negative 3x times, right? So we're going to now subtract plus 0x minus 4. So now we're going to subtract 3x cubed plus 0x squared, and then since we're multiplying by negative 3x, minus 3x, right? So when we do this, these are going to cancel out. This drops down to negative 3x squared. And then our signs change because it's a negative and a negative, so we're going to get plus 3x. And then minus 4. And then this is the last time we can do something, right? Because that's the order right here. And so how many times does negative x squared go into negative 3x squared? That's going to be 3 times. So plus 3. And we're going to subtract out a negative 3x squared plus 0x. And then we're multiplying by 3 plus 3. So when we subtract all this, these are going to cancel out. This drops down to plus 3x. And then we're going to be left with minus 7. And so our results is going to be equal to our quotient, 5x squared minus 3x plus 3, plus our remainder. So plus 3x minus 7, all divided by 1 minus x squared. So long division is kind of tedious, but when the divisor is linear, so we have something like x minus c, then we can use synthetic division. And the process for that is really simple, and I will show you an example. So first step is you're going to write the coefficients of the dividend, so the first thing, inside of this L right here. So 1, 3, negative 1, right? Then you're going to write whatever makes the divisor 0 out by the left here. So in this case, it's going to be negative 2. And then you can replay that if you need to see that process again. And your first step is to drop down this first coefficient right here. And then at every step, you're going to first multiply by the 0. So this becomes negative 2. And then you're going to add up whatever's in this column right here. So this becomes 1 again. And then we multiply again, negative 2 and negative 3. And so we get x plus 1 minus 3 divided by x plus 2. So this is x squared, and then these are going to be 1 less. So this is x, this is our constant term, and then this is our remainder right here. So this is our remainder. And we get x plus 1 minus 3 over x plus 2. And this is actually the first example that we did, and we get the exact same answer. So just like a little confirmation that, yes, this process works the same. Let's do another example where this one, a lot of the values are switched. So again, we want to write out in order. So we're going to have 4. We're going to have 4x to the 5th. There's no x to the 4th term, so we write a 0 as a placeholder. We have a 2x cubed. We have a 1x squared. We have a negative 4x, and we have a negative 11. And then the value that makes our divisor 0 is 1. So let's start this process. 4, multiply by 1, 4, 0. Or not 0, 4. Multiply by 1, another 4, 6. Multiply by 1, 6. 7 is the result. Multiply by 1, 7. 7 minus 4 is 3 multiplied by 1. 3 minus 11 is going to be negative 8. And so we get 4x to the 4th, because we're going minus 1, plus 4x cubed, plus 6x squared, plus 7x plus 3, minus our remainder right here, 8 over x minus 1. So we're going to do 2 more examples. So 2x squared plus 3x plus 4 divided by x plus 4. So 2, 3, 4. And then the value that makes our term here, divisor here 0 is negative 4, right? So we're going to bring that to 2. And then we're going to multiply by negative 4. So that's negative 8. 3 minus 8, that's negative 5. We're going to multiply that again by negative 4 to get positive 20. And we get 24. So our result here is 2x minus 5 plus 24 divided by x plus 4. So we're going to do one more example with synthetic division, and that's going to be in the case that it divides it nicely. So if we have, in this case, x minus 3 is actually a factor of this one, and we're going to get a remainder of 0. And that's actually what it means to be a factor, is you're going to have a remainder of 0 when you divide. So first up, we are going to write our coefficients in order. So 1, negative 3, negative 1, 3. And then we're going to write whatever makes this 0. So in this case, it's positive 3. Bring this down to 1. Multiply by 3 to get 3. Add these up to get 0. Multiply again by 3 to get 0, because 0 times anything is 0. We're going to add to get negative 1. And then multiply one more time by 3 to get negative 3. And then these add up to 0. And so this says that our new term is x squared minus 1. And so we can factor this further into x plus 1 times x minus 1, right? And again, this is the result of division. So this is equal to x cubed minus 3x squared minus x plus 3 all divided by x minus 3. And so what that tells us is that to factor this, you get x cubed minus 3x squared minus x plus 3 is equal to, and then we can multiply both sides here by x plus 3, or x minus 3, excuse me, times x minus 3. These are going to cancel out, and you're left with x plus 1 times x minus 1 times x minus 3. And there you go. You factored it because you knew one of the zeros. Finally, we have the remainder theorem. So if you have a polynomial, p of x, then p of c, for like some value c, is the remainder whenever you divide by x minus c. So just use synthetic division with c in the corner, not negative c, because we're making it so that it's going to be the 0. So always put whatever value you're trying to find in the left. So for example, if we have p of x is equal to x squared plus 3x minus 1, what's p of negative 2? All right, so this is exactly the same problem we had in the original, right? So we have 1, 3, negative 1, and then we're going to put negative 2 in this corner here. We already did this exact division up here, and this was our first example as well. So we already know that this is going to give us a remainder of negative 3. And so p of negative 2 is negative 3. Why does this work, though? Well, let's just take our polynomial here. So we get p of x divided by x minus c is going to equal some quotient term plus some remainder divided by x minus c, right? That's what we've been doing this whole time. And then if we multiply every single side, so multiply by x minus c, multiply by x minus c, this is going to cancel out. And then this is going to cancel out here. This is going to cancel out here. And then because we're multiplying q of x by something that's going to turn into 0, so we're multiplying times x minus c, which is going to be 0, this cancels out to 0. And so we're left with p of x equals r when x equals c, specifically when x equals c, because then x minus c is 0, so multiplying by 0 turns this q of x to 0. I'll write it actually a bit more clear. So we're going to have, so p of x divided by x minus c is equal to q of x plus r divided by x minus c. And so if we multiply both sides of these by x minus c, so we're going to get p of x is equal to q of x times x minus c plus the remainder, right? And then when x equals c, we get p of c equals q of c times 0, which is 0, plus remainder. So p of c equals the remainder. We'll go over another example. So p of x equals negative 5x to the 4th plus 2x cubed minus x squared plus 8x minus 11. And we're going to try to find p of 10. So we're going to put 10 over here as our 0. And we're just going to start doing it. So negative 5. Multiply by 10, we get negative 50. 2 minus 50 is going to be 48. Negative 48, excuse me. Multiply that by 10, it's going to be negative 480. Add those up to get negative 481. And then multiply that by 10 to get negative 4,810. And this is getting pretty big. Add those together to get negative 4,800 and, what is it, 2? And then multiply that by by 10 to get 48020, and then minus 11 plus negative 11. And so that result is going to be negative 48031. And so even though like it might be really hard to find p of 10 normally, we know that this is just going to be negative 48,031 by synthetic division. And that's all for today. Thank you very much for watching that.